Hello, hello. Welcome to
Hey,
this new episode of the Vibe Talking series of the Product Engineers podcast. Today we have Michele Sollecito. He's already a veteran of this community. He's been already in a talk. And yeah, so as you know, we just like to spend some time talking about some interesting posts on the internet, articles, videos, whatever. And there was actually an interesting post that Michele himself wrote on LinkedIn, and yeah, we can just go through it and have a chat about it. Yeah, let's see what happens then.
all right. Hi, Peppe, and thanks for having me, and good to see you again. Pretty
Yeah,
exciting. Let's
likewise.
do it.
So I'm gonna share my screen and let's get started. All right. I think I zoomed in quite a lot, so I think it's clear, also for blind people. Right. Okay, so I think we can just go through it and then we can talk about it. Yeah, so it goes. So what you wrote is, what if we reframe our approach to persistent software challenges? So the term technical debt often simplifies ongoing issues as something easily resolved, when in reality these challenges stem from our system's abstraction diverging from user needs and environmental realities. So then you introduce this new concept called abstraction deviation impedance, right?
Mhm.
So abstraction, which means the models and patterns streamlining our code. The deviation, which is the natural misalignment between these models and evolving business requirements. And the impedance, it's impedance or impedance?
I think so. I think impedance, maybe, no
Impedance,
idea.
yeah.
Yeah, we're the two wrong people for this job.
Yeah, exactly. Which is the resulting friction
Mm.
hindering teams in system maintenance, adaptation, and expansion. Unlike technical debt, this terminology acknowledges the continuous systemic nature of the issue. I like that you always go to the system thinking part. It's like your mark,
Yeah.
right? It goes beyond mere quick fixes, emphasizing the perpetual realignment of our approaches with the software's purpose. By shifting the dialogue, we can address the core causes of software friction. And yeah, how do you navigate persistent abstraction? So yeah, then you kind of ask question to the public. Yeah, very interesting. So I think I'll let you just go through it, explain what you meant with this, and maybe if you could give like an example, would be also interesting.
Yeah. So, mm, first of all, I mean, in theory, I am a big fan of the term technical debt. I use it for years, mostly fascinated to it. Hey, it really explains, the problem is. The reality, though, is that over those years of experience, I didn't have much success in communicating to people, from developers all the way up to executives, the implication of this, right? And the reality is because that is such a, I don't know, a familiar term for people, depending on the country, and but people get exposed to this concept, right? And so what happens is, hey, I got this thing that if I don't keep it under control, it's gonna grow and it's gonna become problematic. But on the other hand, it's kind of needed to grow quickly, and so something that kind of makes sense in business concept. The the two important things I didn't like about the name, and I saw people struggle with this, is one is that it sounds like a quantity, right? So you
Mm-hmm.
accumulate, I don't know, five, whatever I don't know, the currency of technical debt is, five messes perhaps, and then you accumulate seven messes, and then you end up with 12, and then you can talk about, oh, we want to reduce tech debt from 12 to 7, right? Which doesn't necessarily make sense. The second one is that is not, if we wanted to keep it within financial analogies, that is not the only one, right? And you could talk about financial, I don't know, technical inflation as an example, as
Mm-hmm.
somebody commented, right? Which is, hey, tech debt just doesn't just, I don't know, create a problem for us if we ignore it. It also makes everything that we're doing more expensive. And in particular, our capacity is subject to inflation because, I don't know, 2 years ago, doing the same work we do today would have taken 2 weeks and now it takes 2 months. And that's a much scarier problem and is not typically involved in the definition of that, right? When I put together these words, which is abstraction, deviation, impedance, the idea is, hey, these also the other problem with technical debt is that it's kind of like it tries to hint that somehow we made a decision to accumulate this debt, right? Similar to a company that wants to grow quickly, like, hey, I'm gonna go for, I don't know, venture capital or whatever, ask a loan to a bank, use this to grow and then pay it back. Now, in abstraction, deviation, impedance, I don't think it's that meaningful how we got in this situation. And so I like the term because it's a little bit more neutral. It doesn't make it sound like a calculated strategy, which in a lot of cases with technical debt isn't. And the way it works is you're saying, okay, in the ideal world, if we had to build a system today, according to our current understanding and information knowledge, what would it look like in terms of abstraction, right? And now it is instead, right? And that's the deviation aspect of it, right? And so, as you know, as Kent Beck was saying several times, coding is essentially behavior and structure. This is around structure. You can implement behavior in a number of ways, and some ways are going to be very painful in terms of structure, and some ways are going to be really nice. It is an understanding of a deviation from the ideal situation and how things are at the moment. And then impedance is the friction to flow. I really like the term because, like, in electrical engineering, like, impedance is essentially like the resistance that you get to flow, right? Now, I'm talking about electricity, but we can talk about flow of delivery, value delivery, right? And so you get these because there is a deviation between a perfect structure in the ideal world and what you got today.
Very cool, very cool. So, yeah, as I wrote in the comments, I think we should find a name that's a bit more catchy.
Yeah.
I really like the concept.
Yeah, I
I
was
think
thinking about model rot, another
something like that, yeah.
Yeah.
Yeah, that's actually just a little digress. There's a very, very interesting book about this called Made to Stick.
Oh, okay.
Yes, it's written by two researchers that kind of did all this research around how to make ideas stick, and they made this framework called the Success Framework. And yeah, so I think the main thing that is that you need to really use some concrete examples, some real stories. So I think that's why technical debt maybe sticks a bit more because it kind of makes you think, it's a very familiar thing and makes you feel the pain, right? But yeah, I like your concept more actually. So what you're trying to say, if I understand it correctly, is that so technical debt we use it more as not without thinking about the bigger picture, like the business side of it, but just to say, okay, we have developed thing in a shitty way, and now we have this debt because we went very fast without going into. So maybe I'm saying this wrong, but what I understood is that so technical debt we use it more for the, let's say, the quality of what we built so far, because we went very fast and we had to take some shortcuts. Rather, this concept takes more in consideration also the domain and the business side of things, and just okay, we are the technical choices we made are deviating from the problem from the representation of the domain in which we work in.
Yeah,
it's slightly different. Yeah.
There is. I mean, the second aspect you mentioned, yes, I think that's also why I added the word technical in there, right? Which makes a lot of sense to me. The first one, I think, is slightly different. I mean, technical debt, when it was created, according to my understanding, because these days where you ask will give you a million different answers, but it was this idea of doing something well crafted, just not at the level of scope and sophistication and features that you might have wanted because you didn't have time, right? So as an example, if I'm doing something, I'm doing it for 3 users, I might not need a full-blown database that is distributed with backups and resilience and scales up and down automatically. And so I might use, I don't know, SQLite, or even like I don't know, a persistent database on top of a file system locally, right? Now, that one would be implemented correctly, but because I'm not catering to some features, which are, as an example, distributed snapshots and number of users that are increasing, it's going to be
Hmm?
quicker. So in particular,
Yeah.
I'm taking some technical debt. So I'm saying, hey, even if I know that I will need this soon, and if I don't hurry up, we're going to go into all those problems that we discussed. This is a considerate approach, right? So somebody made a calculated decision that was a good idea. It doesn't mean being sloppy. Now,
Hmm.
unfortunately, the problem is the original significance of the term is completely lost in most cases.
Exactly. Yeah.
And the second problem is, in a lot of cases, this just doesn't happen. It's not why people end up in some situations. As you said, right, there might be a difference between how the business went as opposed to what we thought it would be in the beginning or whatever. And so I rather try to avoid the whole why are we in this situation thing as part of the term. I see
Right.
a lot of people. So why is this a problem, by the way? Because I saw a lot of teams that were kind of like calling any situation, no matter how dire, technical debt. And so you're like, oh yeah, the business need to let us know when we need to prioritize technical debt. I'm like, no, this is like a complete mess that we made. The business had nothing to do with it. Nobody authorized you to make a mess, right? It was mostly like, hey, we decide to do whatever. Over time, people modify behavior over and over again without caring about structure at all. Then suddenly everything's on fire, everything takes forever. It's like, oh, we need business alignment on what we need to do about it. It's like, well, I mean, it's a bit convenient.
Yeah. 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 That makes sense. So yeah, as you say that, like I always lived, I was in technical debt because the way,
Mm-hmm.
like I have heard the other people talking about it as like, yeah, we wrote shitty code
Mm-hmm.
and now we have to fix it. I think that's kind of the most accepted
Mm-hmm.
definition. But as you say, yeah, that's not true. Like that's why I really like your this example here, because it actually touches it into what exactly technical that means, and as a gap between, yeah, where we had today with the technology the technology choices we made
Mm-hmm.
and where the business went. Yeah, that's pretty interesting. Yeah.
I think another aspect is the term kind of hints at what the solution might have to be. So another thing I didn't particularly enjoy about technical debt is that, as I was saying, people think of it as a scalar, right? So I clean up a little bit this thing, it's gonna reduce technical debt.
Hmm.
Now, when I say abstraction deviation, this is a very clear picture, right? There's a difference between how things should be and how things are. And if you do some local random improvements, it will essentially amount to nothing. So here's the system thinking aspect of it, which is you need to fundamentally redesign your models and abstraction to try and zero this gap. Right? So it's a very different, I don't know, in an ideal world, people would be paying attention to words, but the point is probably not, as you were saying. But the thing I'm saying is, behind the words is this idea that, hey, if I need to zero this deviation, is essentially a design problem. It's not something that, hey, if I pay here and there, little bit by little bit, Boy Scout rule or whatever, this problem disappears.
Very cool. Yeah, I want to do a quick game with you. I want to try to give this to like perplexity. Let's say
Ooh, let's see what.
I want to try to kind of see what
Oh,
he
you might
thinks about
also
it.
pass it the original. So if you go back, this might be even more fun. There's the original, because this is kind of like the teaser. So if you go into the comments, I got the long article about this description thing.
Oh, okay. I think I can just send it. If it's not to be on paywall, no. Okay,
Yeah, should be fine.
let's try.
Otherwise, I have it on
So,
GitHub pages.
can you explain
Hmm?
this, the concept of this article in layman's
Hmm?
terms? Let's see.
We can ask it for an opinion as well. That'd be funny.
The third guest here,
Yeah.
perplexity. The problem with technical debt. Okay. Uh, so you're saying, yeah, let me.
Yeah, pretty much spot on. Sounds like what we talked about, right?
Humans are useless. We just have to do everything in LLM now. They just know everything. Yeah, so it sounds intentional. It shifts blame to technology. It gets misused. Exactly. And in reality, most software problems don't come from deliberate shortcuts. Instead, they happen because requirements change over time. The original design doesn't fit your needs. Small problems accumulate gradually, and teams make assumptions that turn out wrong. Exactly. And so the new term is abstraction, deviation, impedance. So abstraction refers to how developers organize and think about problems. So it is saying it very simply, right?
Mm-hmm.
So just like architects, I like that. This is where I like it, that it makes like comparisons, right? So just to give you some answers, like
Yeah.
so just like architects create blueprints to simplify the complexity of a building of an house, software developers create mental models to manage complex systems. Perfect. Deviation. This is the gap between what you planned and what you actually have. So your house blueprint might show a simple living room, but reality has kids' toys, work equipment, and pet supplies everywhere, and that's deviation. Okay, I don't know about this.
Yeah, I don't know. I mean,
Yeah.
I mean, even about the first one, I don't think abstraction is just a mental model. It's a very physical
Yeah.
thing in a code base, but fair enough.
Yeah.
I mean.
Well, it becomes a mental model, right? Like it's when you get back to the code base, I think you just think about that thing and you see it physically then.
Yeah.
And yeah, so impedance. This is the resistance to getting things done. In your house example, if the layout doesn't match how you actually live every daily task becomes harder. That's impedance. In software, it means every new feature or change becomes more difficult and risky.
Yeah, this sounds pretty good.
There you go. I'd like to ask, can you suggest a metaphor to explain this concept? I am doing all the research now.
Okay, nice.
Abstraction, the original city plan. Residential for families.
It's a funny analogy because normally in city planning, the result in cities tend to be better than the plan. So this is what happens all the time where people think that they can plan complex systems like cities. And so as an example, they would say, oh, in this neighborhood, we're going to do it this way. In that neighborhood, we're going to do it that way. And then what happens in reality finds its way and people organize around restaurants or whatever. It tends to be better than was actually planned, but fair enough. So it's a good metaphor. Come on, it is. I'm just taking the piss, but yeah.
Yeah. So the city plan is the abstraction. So when your city was first designed, the planners created a beautiful blueprint for residential zones for families, commercial districts for shopping, industrial areas, transportation grid. So the master plan was your abstraction. But how things won't go wrong, the deviation. Over time, several things happened that the original plans didn't anticipate. So unplanned growth, changing needs, quick fixes, drift over time. And now you have a deviation from the original plan. And then you have the daily friction, which is the impedance. So because the city's actual layout no longer matches its organizing principles, everything becomes harder. So the emergency services, utilities, traffic flows poorly, new construction, city inspectors. Every single task now has resistance to flow. Yeah.
I think the only thing I would change is, I mean, once again, it's a good metaphor, right? Especially the last part, the consequences and all. I think the only thing I would change is, and I think this is an important point, is not a difference between a plan and the reality, because, people can mess up plans too. It's a difference between what the best possible design you could ever have, which doesn't mean you will ever achieve it. But it's the difference between the ideal state and reality, not what you planned, right? Because you can plan things that don't make sense. So achieving plans a lot easier than achieving really good abstraction models.
Yeah.
Apart from that,
Right.
yeah, solid.
So maybe you can take some inspiration
Yeah.
out of it. Cool. So I guess we can, like, this could become a way to communicate with the business people even in a better way, right? So we don't. When you say technical debt nowadays, I think if even non-technical people start rolling their eyes, say, "Oh my God, here we are again." But maybe if we said, "Okay, we have designed our system in a certain way because of these constraints we had, this specific situation we were in the past, and now we have deviated from that kind of situation. So now it's time to kind of rethink how things changed and evolve the design, because this can kind of enable some business outcomes and blah blah blah." So yeah, I think it's even a way better way to communicate with non-technical people what's going on, right?
Yeah, I think yes. So I mean, obviously, I haven't been using this term for long, right? But whenever I try to use it, kind of helps a little bit. The biggest difference is first, people are curious because it's a new term, so they try, instead of like assuming what you mean, they will ask you, which is great. The second one is because it doesn't sound like a quantifiable thing. People realize it's not, hey, how much do we lower it tomorrow, right? This is more like, okay, what we want to do about it, when, it could be multiple options, it's a more nuanced kind of discussion about how do you repair a design that's not serving you well.
Have you actually been using this concept at work, like with these words
A couple
exactly?
of times, but yeah, different success.
What was the reaction?
It was, as I was saying, curiosity, raise eyebrows, which is, to be expected. But overall, pretty decent, yeah.
Very good, very good. Okay. So, yeah, let's hope that this inspires someone to kind of dig into this even more. Because I think it's a very important and interesting concept. Yeah. And I think we already reached the end of today's episode. It's a very short one. Yeah, it was interesting to get over this with you. Thank you for joining us.
Nice chat. Thanks for that.
Thank you. Bye-bye.